Have you ever wondered what actually happens when you flush an airplane toilet? Most people assume everything just gets dumped into the sky. It sounds believable. After all, you're flying 10 kilometers above the ground. But if that were true, cities under busy flight paths would have a very serious problem. The truth is, airplane toilets are not simple at all. They're part of one of the most clever engineering systems hidden inside modern aircraft, and the story of how it works is far more interesting than most people expect. To understand modern airplane toilets, we need to go back to the early days of aviation. At that time, comfort simply wasn't a priority. Aircraft were small, flights were short, and toilets didn't exist at all. If you needed to go, you waited until landing. But as aircraft improved and flight times increased, that quickly became a serious problem. Passengers were spending more time in the air, and airlines needed practical solutions. So engineers introduced the first onboard toilet systems, and they were incredibly simple. Buckets. Yes, actual buckets. From a technical perspective, this worked, but from a hygiene and safety standpoint, it was far from ideal. Turbulence could easily cause spills, cabins were cramped, and the experience was uncomfortable for both passengers and crew. It became obvious that aviation needed something better. One of the first real engineering solutions was the gravity-based toilet. The idea was surprisingly straightforward. The toilet connected directly to a valve in the aircraft's fuselage. When the passenger pulled a lever, the valve opened and waste exited directly into the airflow outside the aircraft. No pumps, no electronics, just gravity doing the work. Engineers liked this solution because it was lightweight and mechanically simple. Fewer components meant fewer failures. Passengers also appreciated that airflow carried odors away almost instantly. But the system had serious drawbacks. Waste removal wasn't always complete. Odors sometimes returned into the cabin, and releasing material directly into the atmosphere created obvious safety concerns. So once again, engineers had to rethink the system. Later designs introduced water-based flushing systems. This improved comfort significantly, but it introduced another major problem: weight. In aviation, every kilogram matters. Carrying extra water increases fuel consumption and operating costs. And water tanks created another limitation: capacity. If the tank filled up during a long flight, the toilet simply stopped working. Now imagine that situation halfway through an international journey. Clearly, something more efficient was needed. Then aviation encountered one of its strangest problems ever: something called blue ice. To control bacteria and reduce odors, aircraft began using a disinfectant chemical known as blue fluid. It worked well inside the system, but early toilet designs were not perfectly sealed. If even a small leak developed, that blue fluid could escape outside the aircraft. At cruising altitude, where temperatures can drop to around -50 degrees Celsius, the liquid froze almost instantly. Over time, frozen waste mixed with blue disinfectant formed solid chunks on the aircraft's exterior. Sometimes these chunks broke off during descent. And yes, there have been real cases where pieces landed near houses and vehicles on the ground. Rare, but real. Incidents like this made one thing clear: aircraft toilet systems needed a completely new approach. The breakthrough came in the 1980s. Instead of improving water systems, engineers asked a different question. What if toilets didn't rely on water at all? What if they used air? That idea led to the vacuum toilet system used in modern aircraft today. From the outside, modern airplane toilets look completely normal. Same seat, same flush button. But inside, everything works differently. Each flush uses only a very small amount of water, typically around 100 to 200 milliliters, just enough to rinse the bowl surface. The inside of the bowl is coated with a special non-stick material that prevents waste from sticking. But the real magic happens beneath the bowl. There is a sealed valve separating the cabin from the waste system. When you press the flush button, that valve opens for a split second. Air rushes through instantly, and everything inside the bowl is pulled into the system. That loud whoosh sound you hear isn't water. It's fast-moving air created by pressure difference. And this is where aircraft physics becomes incredibly useful. At cruising altitude, the air pressure outside the aircraft is much lower than inside the cabin. Engineers take advantage of that difference. When the valve opens, air naturally moves toward the lower pressure environment. This helps pull waste into the storage tank quickly and efficiently. In other words, once the aircraft reaches altitude, the toilet system becomes even more effective while using very little additional energy. It's a clever example of engineering working together with natural conditions instead of fighting against them. Despite what many people believe, airplane toilets never release waste into the sky. Everything is stored inside sealed waste tanks. These tanks are specially designed to handle vibration, pressure changes, and extreme temperatures during flight. Sensors constantly monitor how full the tanks become. If necessary, the system can automatically disable flushing to prevent overflow. After landing, a ground service vehicle connects to the aircraft and safely removes the waste. There is no mechanism that allows pilots to dump it mid-flight. That idea is simply a myth. Interestingly, airplanes are not the only vehicles that must manage waste on board. Ships also handle this challenge, but ships operate in a completely different environment. Weight is less critical, pressure differences are minimal, temperatures are more stable, so ships can rely on simpler storage and treatment systems. Aircraft, on the other hand, operate under constantly changing pressure and extreme cold conditions. That's why their systems must be lightweight, sealed, and highly efficient. Another common question passengers often ask is whether onboard drinking water is safe. Technically, yes. Aircraft water is loaded on the ground using specialized service vehicles and must meet strict quality standards. The storage system is disinfected regularly, and water is usually kept on board for no more than about 72 hours. However, because that water travels through onboard pipes and tanks, some pilots prefer bottled water instead. Tea and coffee are generally considered safe because the water is heated before serving. And here's one final surprising story connected to airplane toilets. Some first-time passengers once assumed the blue liquid inside the toilet bowl was just water. A few even tried washing their faces with it. They walked out of the lavatory with bright blue faces. It sounds like a joke, but pilots have confirmed incidents like this really happened. Today, airplane toilets are clean, sealed, lightweight, and extremely efficient systems designed to operate 10 kilometers above the ground. From simple buckets in early aircraft to advanced vacuum technology powered by pressure differences, their evolution is a perfect example of how aviation engineering solves unusual problems in smart and unexpected ways. So now I'm curious, do you usually drink tea or coffee on airplanes? Or do you prefer to avoid onboard water completely? And be honest, do you still flinch a little when you hear that loud whoosh sound?